So now that we've established why the order of operations is important to begin with, and if you haven't seen that video, there's part 1 there for you to go and have a look at. Let's have a look at now applying the order of operations to a series of problems and some things that we just need to be keeping in mind as we work through it. So let's just apply it to these 4 problems to begin with. Our order of operations says we need to check for brackets, need to check for exponents. We can see in our first problem on the left here, this 6 plus 8 times 4 does not have any brackets or exponents. However, it does have multiplication. Okay, so the multiplication is the first thing that we're going to need to complete here. And we're going to keep the 6 plus in the same order that it's in. All right, we're going to do the 8 times 4, all right, which is going to be 32. We then go addition last because that's all that's here now. So 6 plus 32 will be 38. Okay, nice and simple. The second problem, we've got 3 plus 7 take 5. So we've only got addition and subtraction. Now, we are going to complete this in order from left to right because addition and subtraction are the same level. Now, it just happens that addition is listed first here, so we are going to do the addition first. However, if this was 3 subtract 7 add 5, we would do the subtraction first. Like we would complete this left to right. So, in this case, we've got 3 plus 7, which is going to be 10. Subtract our 5 still. Then 10 subtract 5 is 5. Moving on to the next problem. We've got 3 times 8, subtract 6 times 5. Now, in this problem, we don't have brackets or exponents again. We don't have any division, but we do have 2 sets of multiplication. So we have to do both sets of multiplication before we can do the addition or subtraction here, in this case, subtraction. So we've got the 3 times 8, which is going to be 24. We are going to subtract our 6 times 5. We could have done 6 times 5 in our head as well, but I'm just going to complete it left to right in that order. So we've got 24, subtract the 6 times 5, which is going to be 30. Then 24 subtract 30 will be negative 6. Okay. With our fourth problem, we've introduced brackets. Now, we have to apply the order of operations inside of our brackets. However, there's only one operation to apply. So in this problem, we need to do the 11 take 7 first. So 11 take 7 will give us 4, then times 2 at the end. Now, we need to look at our next step, which will be the division multiplication step. So we need to obviously perform the multiplication here next. So 4 times 2 will be 8. So we need to plus 8. And then we've got the 3 plus 8, which is 11. And that's how we apply the order of operations to these types of problems. But let's have a look at a couple of more. All right, and I'm going to look at them first, then talk about things that we need to keep in mind. So this next problem, we have multiple sets of brackets. And we know that we have to do the brackets first. So what do we do here? Well, we solve the innermost brackets as our priority. So in this case, it's the 9 divide 3 as our first priority here. So we've got 12 plus the 9 divide 3. 9 divide 3 is 3. And then we subtract our 4 squared. Now we still have brackets, so we have to continue working our order of operations within those brackets first. So the next step is the 12 plus 3, which is going to be 15. Subtract 4 squared. We're now done with all of our brackets, but we do have an exponent. And the exponent's the next thing we need to solve. So the exponent is going to be the 4 squared. We're subtracting it. So 4 squared is 16. So it's going to be 15 subtract 16. We're left with one operation left, so that's the obvious one that we do. And we arrive at an answer of negative 1. Moving to the next problem though. The next problem has a fraction in it. And we have to remember that a fraction line is division. But we also have to remember that essentially, we have to remember that whenever we have a fraction, we actually have invisible brackets around the top of our fraction and the bottom of our fraction. So before we can perform that division, we actually have to completely solve the top of our fraction and the bottom of our fraction independently first, and division is the last step that we perform. So what that means is we think about it as the top of the fraction or the numerator as its own problem, which means we've got this 12 plus 5 takes 7. The 5 takes 7 is inside brackets. So it means that we need to prioritize that subtraction first because that's the brackets. So we've got the 12 plus 5 takes 7 is negative 2. This is all going to be divided by, and we do the same thing on the bottom. We need to prioritize the addition, the 6 plus 3 first because it's inside brackets. So this is going to be 18 divided by 6 plus 3, which is 9. Now, looking at the numerator again, or the top of the fraction, we have 12 plus negative 2. This is adding a negative. That's the same as subtraction. So 12 take 2 is going to be 10. 18 divided by 9 is going to be 2. And now we can finally perform our division. So 10 divided by 2 is going to be 5. And that's how we solve those types of problems. So there's some things to keep in mind, just some extra things as we work through. If an expression contains one set of brackets, evaluate that brackets first. However, if it contains 2 or more sets of brackets, you need to evaluate the innermost brackets first. An example can be clearly seen just here, but also here if you think about the green brackets as well. If you have a division line in fractions, it acts as a grouping symbol, which means you have to think about that problem as having 2 sets of brackets, invisible brackets at the top and the bottom, the numerator and the denominator. And you must solve the numerator separately, the denominator separately, before you finally do the division. So there's just some extra things to keep in mind as we work through the order of operations. I hope that was helpful. But yeah, that is the order of operations.